Then any confusion in the previous topic, that is object placed at focus, focal point? Any confusion in drawing the ray diagram? Use your quick reaction or ask me if there is an issue. If it is clear, we will go for the next position to draw the ray diagram. So everyone is clear. Then the next one is position. What is the remaining position? It is not between, inside the focus. Sorry, position is written wrong. Object placed between P and F. P and F. So this is the position for us, right? Next position is between P and F. So here same logic following, but here in this case you will find one difference. What is that? What is the difference to the previous and now? Can anybody? Can anybody? What is the difference? Observe closely. I followed one difference in drawing the mirror. First, here I moved. Come again.
Mirror is between.
Right. Just I moved the mirror surface middle to the paper. Right. Previously, we drawn left side of the page. Have you seen? In the previous position, left side of the page. Now we came to the middle of the paper, right? So only for this position, I am drawing the mirror like this. Remaining all are same, left side of the page. Why? We will see that. So here, object now placed between P and F, between P and F. Then completing the ray 1. R1 to meet the mirror surface, that is, which is parallel to the principal axis. After that, what is next ray possible here? Passing through the focus, R2, possible? R2 is possible?
No, sir.
Not possible. Then we will go for what? We'll go for R3.
Rule 3.
Rule 3. R3 is possible or not? Just check, is it possible or not by connecting the top of the object and the center of curvature, right? So it is possible. Then construct a R3 here. Then what to do? Complete the reflected rays from the point of incidence, right? So R1, first we will go for R1. So what is the behavior of R1? After reflection, it passes through the focus. So connect the point of incidence and center of focus. Connect the point of incidence and the focus. Then complete the reflected light ray. Then R3. Connect that R3 and center of curvature as you see here. Then draw the light ray, reflected light ray. So is it clear how to draw? Then tell me here simply Medhasri, just you keep on silence every time you are only leading. So for other I am asking anyone here that reflected light rays are going to meet each other after reflection in front of the mirror. Anyone? Do they meet after?
No.
No. Then what to do in
No.
this case? Not going to meet. What to do? What to do? Any other? So if you are not getting the converging point, try to obtain the diverging point. Why? Drawing the backward rays behind the mirror. Go to the behind mirror. So I'm moving behind the mirror. So image formed, image not formed in this case, right? Image not formed in this case in front of the mirror, not at infinity. Image not formed in front of the mirror in this case, right? Then we are moving behind the mirror. So draw the ray backside. This reflected light ray only extended behind the mirror using the scale. Then second ray also backward. So what happened here? Do they meet behind the mirror?
Yes, sir.
Yes.
Sir.
So we got a point, common point at this spot. So what to do? Here you have to draw a perpendicular onto the principal axis from the point. So this is what image for us, right? What the difference? If you observe closely to the previous positions with this. We got diverging point, that behind the mirror. That is behind the mirror. So here, look at an image. Is it faced opposite to the object or same side to the object? That means above the principal axis or below the principal axis? Where do you see?
Above the principal axis.
Both object and image both faced above the principal axis. So what the characteristics we can write in this case? Characteristics of the image.
Virtual image and direct image.
Virtual image and direct image, right? Virtual and direct image, right? So simply here we will write the characteristics as follow. So the image is virtual image because I obtained the rays coincides each other by the backward rays, not by the reflected rays. That's why it is virtual image. Virtual image formed on the surface. You can see the image in this case on the surface of mirror, right? Then that image type is erect image because image above the principal axis is like the object. Object also above. So both are faced same side. Then here the size is comparing with the object more greater. So enlarged image. And finally the position of image is behind the mirror. Why I'm saying behind only? Because I don't know the any particular point behind the mirror, like a focus and center of curvature. Do I know? Nothing. So that's why I said behind the mirror. So these are the characteristics of the image. With these ray diagrams of concave mirror are completed. Any confusion in any ray diagram? If nothing, just give me your quick reaction. Right. Now we'll go for another topic that is related to the convex mirror, right? Related to the convex mirror, that are firstly rules to draw the ray diagrams. That which is given in the page number of your textbook is page number 11. Open the page number 11, you will find them. Right? So here, what are the rules? So we will follow the same method. R1, R2, R3. R1 is what? Parallel to the principal axis. R2 is passing through the focus, and R3 is passing through the center of curvature. But here in this case, you will find a difference comparing with the concave mirror. So look at that. First rule is that ray which is parallel to the principal axis and incident on a convex mirror. Then what happens? I am not going for the generalization. I will find the generalization through my diagram. I won't go for the remaining part. Only I am taking a ray that which is parallel incident on a convex mirror, parallel to the principal axis and incident on a convex mirror. So for this, I am drawing the convex mirror using a center of curvature, cutting the arc. Then the shaded portion is concave surface. So this mirror is what? Convex mirror. The type of mirror is convex mirror. Then what to do? Identify the pole and identify its center of curvature. Sorry, focal point. Then can anyone tell me the difference to the convex mirror and concave mirror? What you feel difference? Vikrant, Sricharan, Tejaswini, no response from you. Can anyone give me the difference to the concave mirror and convex mirror? Except them, their reflecting surfaces. నేను అడిగింది రిఫ్లెక్టింగ్ సర్ఫేసెస్ గురించి కాదు, షేడెడ్ రీజన్స్ గురించి కాదు. ఆ రెండింటిని వదిలేసి చెప్పండి. ఐఎమ్ నాట్
concave mirror, converging mirror.
Concave mirror is convex. Okay. Other ఇంకా ఉన్నాయి. Just look at the points, identified points. Think about them. For a concave mirror, you have the points like this. Now find the difference.
The points are in the mirror.
Inside the mirror, behind the mirror. How to say that? Behind the mirror.
Behind the mirror.
Now points are located behind the mirror. What they are? Focus and center of curvature. Then what about its focal length? Its focal length is same. The distance between the pole and focus. Then what about its radius of curvature? Same. The distance between the pole and the center of curvature. Then tell me which are located behind the mirror for the convex mirror. These all focus, focal length, center and radius of curvature are located behind the mirror. For a convex, for concave mirror, all are in front of the mirror. Look at them. They are in front of the mirror. This is the difference. Are you clear? Are you clear? Quick reaction. So remember these differences, right? They will help you in solving the problems, right? So I'm clearing this information. Now we'll go for topic. So the ray which is parallel to the principal axis and incident on a convex surface. So what to do? Using the scale and drawing the parallel light ray to incident on the convex mirror using the same logic, exactly width of the scale. So now the ray incident on a convex mirror. Then find the normal at that point of incidence for the incident light ray. So normal is drawn. Then measure the angle of incidence, right? Using protractor at a point of incidence. So place your protractor like this to find out angle of incidence and angle of reflection at a time, right? So angle of incidence is observed as here 14 degrees. Then what about angle of reflection? Also 14 degrees. So 14 plus 14, 28 it will be, right? So at that point, I'm going to identify or recognizing one point there. So recognize a point at 28 degrees. Then what to do? Remove your protractor after identifying the angle of reflection, right? Equal to angle of incidence 14, 14. Then what to do? Just construct a reflector light ray joining the point of incidence and the identified point. How it is looking like? Will it meet any point known to you? Focus or center of curvature? Anyone give me your response? Will it meet? principal axis after reflection for any extension. If you extend this, will it meet to the principal axis? No.
No, sir.
Very good. No, it won't meet the principal axis because it is moving away from that reflected light ray, moving away from. So what to do in this case? We have to move in the backward direction. So use your scale and extend it in the backward direction. What you observed? What you observed? If I extend that reflected light ray in the backward direction, will it meet the principal axis?
Yes.
Yes. Where? It is going to meet.
Focus
At
line.
focus.
Right, at focus, but it is actually happening or virtually we are imagining. It is not happening, just we are imagining by extending in the backward direction. So simply it appeared to emanate from the focus. మనం ఏమనుకుంటాం అక్కడ నుంచి వచ్చింది అనుకుంటాం, right? So that is happening in this case. So R1 is what? Parallel to the principal axis. After reflection from the convex surface, what happens? It appeared to emanate from the focus. That reflected light ray appeared to emanate from the focus. So this is the generalization. Is it clear? Go for quick reaction. If there is any doubt, we will discuss. There is any issue for anyone? Rohit. Rohit Sricharan. No issue. Okay. So we'll go for next one. So what is second rule? What is second rule? For concave mirror, passing through the focus, right? Passing through the focus. But in case of convex mirror, passing through the focus is possible. Why? Why not? Anyone? Question is given you, right? For a convex mirror, I know the focus which is located behind the mirror. Now the rule 2 is passing through the focus. Is it possible? Anyone? Why? Why not? Not possible because it is located behind the mirror. So how you can incident on the reflecting surface from the back side of the mirror? Impossible. So it is not passing through the focus. Then what to do? Virtually we can imagine. What we can imagine? It appeared to meet the focus, right? So how to solve that? Then look at here. So I can draw the rule 2 using the convex mirror. So rule 2 is what? The light ray incident which is directed to focus, towards the focus. Akkadiki potunnattuga untadi then pole. That is the meaning, right? So look at on the screen. So drawing the convex mirror as you followed in the previous case. So completed. Then what to do? Just I directed a ray that which appeared to meet focus, but it won't meet. Will it meet? No, because reflecting surface does not allow the light ray to pass through it. It will send back, right? So what happens in this case? So we'll follow the same logic. Connect the point of incidence given by the light ray, point of incidence on the surface with the center of curvature. So normal is drawn. I got normal. Then what to do? Use the protractor and measure the angle of incidence, right? As you see on the screen. So what is the angle of incidence? It is almost 14 degrees, right? What I observed here, 14 degrees I measured. Then what to do? I have to measure the same angle another side to the normal, 14 degrees, right? Then recognize a point here at 28. Then remove your protractor. This reflected light ray angle identified by me as a point at this spot, right? Then complete the reflected light ray by connecting the point of incidence with the identified point. I shown you with the scale. Then complete the reflected light ray. Then look at here. Is there any gap increased between the principal axis and the reflected light ray? Anyone? Is the gap increased between the reflected light ray and the principal axis? How it is looking like? Are you in the meeting or not? Kaushik, Vikrant, Tejashwini, come.
Yes, sir.
Tell me what you observed here. Not increased any gap. So what we can call in this case, it is parallel to the principal axis. We can say it is parallel to the principal axis. Mute.
Okay.
Right. So it is parallel to the principal axis. This is my generalization. So a ray of light which is incident directed towards the focus of convex mirror then becomes parallel to the principal axis after reflection. Is it clear diagrammatically or not? Go for quick reaction. So this is one of the generalized rule for us, right? Generalized rule for us. Then we'll go for third rule here, right? We will go for third rule here. What is third rule? Passing through the center of curvature for a concave mirror. For convex mirror, passing through the center of curvature is possible or not? Possible passing through the center of curvature and meets the convex surface, reflecting surface? Not possible because that point is located behind the mirror, right? Behind the mirror. So in this case also, we will have a light ray that which appear to meet or directed towards the center of curvature of a convex mirror, right? So this logic we will follow. So I am using scale to connect the convex surface with the center of curvature. Are you following? How I connected convex surface above the principal axis and the center of curvature is connected with the scale at any point on the curvature. You can use any point. Then what to do? Draw a light ray onto the mirror surface, instant light ray, right? Then how it is directed? Towards the center of curvature. So you can get clarification by drawing the dotted lines inside the mirror from the point of inside. Point of instance inside the mirror. So now look at instant light ray appear to meet the center of curvature or directed toward the center of curvature. Am I clear? Am I clear in my explanation part? Yes. Then what to do? We have to go for logic. That what? Law of reflection. Angle of incidence equal to angle of reflection. Then what is the angle of incidence here? Vikrant. Kaushik. What is the angle of incidence here?
0 degrees.
Yes. Angle of incidence is what? 0 degrees. Then what about angle of reflection? Also same, 0. Then what about the reflected light ray direction here? In what way it will be reflect back? Answer చెప్పకపోతే అర్థం కానట్టే మరి.
It reflects back in the same direction.
Very good. It retrace its path. It retrace its path. So here simply, if the light ray incident normally, in this case, what we can say normal incidence, right? So it retrace its path as you see here. Clear? This is what reflected light ray. So incident light ray, reflected light ray, maintaining the same path. Am I clear? Right. So these are the rules. R1, R2, R3. What is R1 here? R1 is parallel to principal axis. What is R2 for convex mirror? Directed towards focus. What is R3? Directed towards center of curvature. Right? These are the three rules we can follow in the construction of ray diagrams for convex mirror. Right? These rules help you to draw the ray diagrams of convex mirror. So let us see the convex mirror ray diagrams. What is the time now? Okay, we have 15 minutes. So I will complete this part. So let us clear this. Then we'll go for the topic is ray diagrams of a convex mirror. Ray diagrams of a convex mirror. So convex mirror. I am constructing the convex mirror using the scale. First of all, I will draw the convex mirror. Right? Sorry, convex mirror principal axis. Horizontal line. Then what to do? Here you can draw the convex mirror middle of the paper. Not left side, not right side. Middle of the paper. Right? Having the enough gap behind the mirror. It may be 10 centimeters or 12 centimeters. Right? Maintain that gap. Then cut the arc. Complete it. That means make it as mirror, which you required. So I required a convex mirror. So that's why I shaded concave surface. Shaded reason is concave surface. So convex mirror is completed. Identify the pole and its focus. Focus always midpoint of the pole and the center of curvature. Maybe in front or behind, respective to the mirror. Okay. Then what to do? We have to place the object. So for placing the object, what logic I said you? I said to you one logic. What the logic is? Height of the object always equal to anyone?
Width of the scale.
Very good. Width of the scale. Why I am following that logic?
To get a parallel beam.
To draw the parallel light ray, right? For instance, on the mirror surface. So before removing the scale, construct the parallel light ray also. R1 is completed here. R1 completed here. So R1 is completed. Then what the next possibility? What the next possibility is? Anyone? Next possibility is R2 or R3? Which I select? Anything is possible. They are directed towards the focus or center of curvature. But remember, we are not going for the second. We are always selecting a R1 and R3. R1 and R3. Always for any position of object in front of the convex mirror. Always I am depending on the R1 and R3. So what is R3? What is R3? Anybody? What is R3? Don't know?
Passing through center of curvature.
Come again. Medashri, you made a mistake. Just you said one mistake. Passing through. Possible? Passing through is possible? Not possible. Right? Passing through is not possible. Then simply here in this case, what it is saying is directed towards the center of curvature. Clear? Directed towards the center of curvature. So what to do? Just look at the screen. I joined. Sorry. So first completing the reflected light ray. Right? To cut the normal first at the point of instance. Right? So normal is drawn for the first ray R1. Then second ray. So here for the second possible ray, I am selected R3. R3 is what? Directed towards the center of curvature. So top of the object and center of curvature joined with the scale as you see on the screen. Is it clear how to construct R3? How to place the scale to construct R3? Look at on the screen, right? Then draw the incident light ray from the same point of the object. This is R3. See, directed towards the center of curvature. Is any confusion for drawing R3? Use your quick reaction. Is there any confusion how to draw the R3 for convex mirror? So no confusion, right? So R3 also completed. Then what to do? Complete the reflected light rays. What is the behavior of R1 after reflection from the convex mirror? Anyone? Anyone? R3. Sorry, R1. I want R1 behavior after reflection from the convex surface. It seemed to be emanate from the focus. It seemed to be emanate from the focus. So what to do? Just connect the point of incidence and the focus for the R1. As you see. So draw the reflected light ray. So it is appeared to emanate from the focus. Is it clear? Is it clear? Yes. So next, R3 behavior. What is R3 behavior after reflection? Help me to draw the reflected light ray for R3. It is along the principal axis, sorry, along the normal. So along the normal, it remains along the normal only in front of the mirror. So retrace its path. So draw the reflected light ray like this. Then look at the reflected light rays. Do they meet each other? Do they meet each other in front of the mirror? Never meet for any extension, for any length, right? They never meet because the gap is increasing between them. See here, the gap is less here, but if you move away from there, gap is increasing. So diverging, the light rays are diverging after the reflection. So in this case, we cannot get the image in front of the mirror. So where do you get the image? Behind the mirror, because in the backward direction, they are going to meet, or they are appeared to separate from this point, diverging point. So this point is image point of a top of a object. So image formed for top of object. So this is top of image. Where is the bottom? Where is the bottom? Always the bottom
On the principal axis.
on the principal axis. Then what to do? We have to construct a perpendicular to the point of image, top of image. So I will clear this information. Now look at. Is it clear? So the image is obtained at behind the mirror. What is exactly location? Between P and F, because I know the points behind the mirror. So it is between. The reason is what? Between. So image is formed between P and F. Size of the image?
Diminished.
Smaller, diminished. Right? Then type of image, erect or inverted?
Erect image.
Why erect? Because it is faced same as the object. Then type of image, virtual or real?
Virtual image.
Because it is given by the diverging point. So if you get any image by the diverging light rays, then it is called a virtual image. So characteristics are written like this. So characteristics of the image are virtual image, erect image, diminished image, and it is behind the mirror. You are able to write the position also between P and F. Then you may ask one doubt. Sir, while you are explaining the ray diagrams of concave mirror, you have shown the positions. What are the possibilities are there? Various positions in front of the mirror. But why don't you show the positions for various possibilities in front of the convex mirror? అడగలేదు ఎవరు? ఒకవేళ అడిగితే ఆన్సర్ ఏమొస్తుంది? నేను అడిగాను, మీరు చెప్పండి. I am not given any possible positions to keep the object in front of the convex mirror. Why? Why I am not given? Because you are unable to move the object in front of the mirror. You cannot go infinity in front of the mirror. Yes, we can go, but I am not given possibilities. Why? So longest possibility, very far distance, is infinity. Very far is infinity. Minimum distance is what? That is very close in front of the mirror. Right? Very close in front of the mirror. So except these two things, do you know any other known places in front of the mirror? ఎవరికైనా ఇంకేమైనా పాయింట్స్ తెలుసా in front of the mirror? Like focus, center of curvature. ఉన్నాయా ఏమన్నా? No places. So that's why here only one possibility is there. Always the object is said to be placed. Object always said to be placed before convex mirror. Any confusion? ఏదైనా కన్ఫ్యూజన్ ఉందా ఎవరికన్నా? అడగండి ఇప్పుడే. Use your quick reaction if you are clear. So only one possibility is there, right? So we have to see what happens if you put the object at very far distance. That means at infinity. Adi repu chuddam. Okay. So any confusion in this topic? Any confusion in this topic?
No, sir.
No. Right. Thank you. So give me your response about today's class and leave the class. Medhasri. Medhasri.
Yes, sir.
Clear everything?
Yes, sir.
Right. You can leave
Yes,
now.
sir.
Kaushik. Kaushik.
Sir.
Clear everything?
Yes, sir.
Vikrant.
Clear, sir. Understood.
Okay, you can leave now. Abhinay.
Clear, sir.
Right. Thank you. Leave the class. Sri Charan.
Yes, sir, clear.
Rohit.
Yes, sir. Clear.
Surajita.
Sir.
Okay. Tejaswini.
Clear, sir.
Right. Thank you. We'll meet tomorrow.